Before we start going over this quiz, let's talk about what you do and do not have to memorize. There are two equations that will not be given to you on the AP exam. The first equation for fluids that you will need to know is density. Now, when I say this will not be given to you on the AP exam, it will also not be given to you on my quiz tomorrow. Density, rho, is mass per volume. So if you haven't memorized that, do so now. So that's density, or rho, equals mass per volume. The other one that will not be given to you is Pascal's principle. I suppose because it's not really an equation so much as it is a statement of fact that pressure is the same everywhere. But that's P1 equals P2, and its more useful form, F1 over A1, equals F2 over A2. Force over area at one spot equals the force over the area at another spot for any continuous container. That's just any container that isn't broken up. Alright, so you should memorize this, Pascal's principle written in terms of force and area, and you should memorize density. Those two statements will not be given to you on the AP exam, and will not be given to you on my quiz. I'm going to do a quick walkthrough of all the equations and concepts you'll need to know for this exam. If you want sample problems, those are in the PowerPoint that is up at the top of this website post. I'm not going to work through those example problems. They're all ones we've done in class, so they should be somewhere in your memory or notes, but they are all in that PowerPoint. First off, density. Density is how much stuff there is per volume, and the formula for density is rho equals mass over volume. Density is in kilograms per meters cubed, mass is in kilograms, and volume is measured in meters cubed. When we're dealing with fluids, we usually don't talk about mass. Instead, we'll talk about rho times velocity. And if you solved out the equation rho equals mass over volume, for m, we'd get rho v equals m. So this is mass, but because the volume of a fluid changes depending on your situation, we talk about rho v instead of just mass. The density of water, which you've come to realize in this unit is important, is 1,000 kilograms per meter cubed. This fact will not be given to you on the test, on the quiz, most likely, or on the AP test. Got to remember it. So, density of water is 1,000 kilograms per meter cubed. Anything with greater density sinks, anything with less density floats. Pressure is force over area, where force is measured in newtons, area is measured in meters squared, and pressure in pascals. Now, pressure can also be measured in atmospheres, and 1 atmosphere is 10 to the 5th pascals, or 100,000 pascals. Okay? Pressure is how much of force gets spread out over an area. So notice on these high hills, both get the same force, so F equals F. But one has a small area, and one has a big area. So this one gets the high pressure, because it's F over small area, and this one gets the low pressure because it's F over a big area. So think of pressure as how much of force gets spread out over an area. We can measure a couple different types of pressure. Usually when we talk about measurement, we mean gauge pressure, which is rho GH, so density times gravity times height. However, you might also be asked to find the absolute pressure, P, which is initial pressure plus gauge pressure, rho GH. P is absolute pressure over here, so P is absolute pressure. P naught is the initial pressure, and it's usually 1 atmosphere, or 100,000 pascals. The density of a fluid, rho, is measured in kilograms per meters cubed. Gravity is 10 meters per second squared, or 10 newtons per kilogram. And the height of the fluid is measured in m. So we've got pressure equals absolute pressure equals initial pressure plus gauge pressure, which is rho GH. And remember that the h is the height above the point wherever you're measuring the pressure. So something might say, what's the pressure at the bottom of a bucket? And a lot of people might be tempted to say, oh, well, the bottom has 0 height. No, what we mean is the height of the fluid above wherever you're measuring. So if something was 10 meters deep at the bottom of the barrel, the height would be 10 meters, because there's 10 meters of fluid above it. Pascal's principle, which you learned, is pretty useful and neat, especially if you're dealing with lifting something up. You'd have one side of a hydraulic jack, which is basically just a fluid container that has a small area, and so you can supply a small force. And then on the other side, you could have a place that has a big area, so big area, and you can get out of it a big force. And that's Pascal's principle, that the pressure on one side equals the pressure on the other, meaning the force over the area on one side equals the force over the area on the other. Pascal's principle. And there's buoyant force, which is measured with rho times volume times gravity. Force is, of course, in newtons. Density is in kilograms per meters cubed. The volume submerged in meters cubed. And gravity is 10 meters per second squared, or newtons per kilogram. Now, the tricky part here is remembering that rho is the rho for the fluid, and V is the volume of the object submerged in the fluid. So if you think about taking a rock and dropping it into some water, the rho is the rho of the water, so the density of the water, and the volume is the volume of the rock. And so you got to remember rho is the fluid, V is the volume of the object, not the fluid. Remember those ranking tasks? There's a couple of those at the end of tonight's post that are important. You should try them. And the key on both of them is remembering that rho, or density, is the density of the fluid, and V, or volume, is the volume of the object submerged. So remember that. There's also the principle of continuity, which says that area times velocity, so this is a small v, therefore velocity, at one part of a container with flowing fluid equals the area times velocity at another part of a container with a flowing fluid. Area times a velocity is a volume flow rate, and the volume flow rate in any container is the same everywhere. And that's what the principle of continuity tells us. A is the cross-sectional area given in meters squared. V is the velocity of the fluid given in meters per second. And AV is the volume flow rate, which would be given in meters cubed over seconds. So that's a volume over a time. That's a volume flow rate. So both of those sides are volume flow rate. That means that the volume flow rate on one side is equal to the volume flow rate on the other side. Principle of continuity. And then there's Bernoulli's equation, which is the pressure at one point plus the potential energy per volume at that point plus the kinetic energy per volume at that point equals the pressure at the second point plus the potential energy per volume at the second point plus the kinetic energy per volume at the second point. So Bernoulli's equation tells us that pressure is conserved because pressure is just energy over volume. So Bernoulli's principle is telling us that energy per volume is conserved. And it's most useful for answering questions like, what's the pressure at one point in a pipe? How high does this pipe have to be to make the pressure this much? What speed does the fluid have to be going to make the pressure this much? And so Bernoulli's equation can tell you all kinds of things about a flowing fluid. The big takeaway of Bernoulli's equation that most people remember above the equation is that high pressure means that you have low velocity, and low pressure is related to high velocity of the fluid. So the faster a fluid is flowing, the lower its pressure. The slower a fluid is flowing, the higher its pressure. I remember we did lots of problems where we related big area equals small velocity equals high pressure, and small area equals big velocity. That comes from the principle of continuity, by the way, the relationship of area to velocity equals low pressure. So area and pressure do the same thing, while area and velocity do opposite things. If area gets small, pressure gets small. But if area gets small, velocity gets big. Something I should note is that on the AP exam, and therefore on my quiz, Bernoulli's equation is written like this: P plus rho g y plus 1/2 rho v squared equals constant. That means that the other side of the equation would be the same, and that you would just have to put in the 1's everywhere, and then on the other side, the 2's everywhere. Okay? So the formula sheet for the AP exam just says P plus rho gy plus 1/2 rho v squared equals constant. You have to know that that means on the other side of the equation is P2 plus rho gy2 plus 1/2 rho v2 squared. Okay? So that just means that both sides are the same. They just didn't write it twice on the equation sheet to save space. And you should definitely know what that means. Don't be surprised when you get the formula sheet and it says P plus rho gy plus 1/2 rho v squared equals constant. And that's it. Have a good night and good luck on the quiz.